Hi everyone. In this video, I'm going to show you how to compute producer surplus. So last time we discussed consumer surplus. I hope you were able to compute that. Now let's go ahead and see producer surplus. It's very similar to a consumer surplus. We set up that definite integral, but we're going to interpret it, of course, a little bit differently. So think of it as you have some supplied curve. So let's suppose this is our quantity and price axis. So let's call this quantity and let's call this price. And you have some curve. Let's maybe something like that. Call that the supply curve. And we're going to label that to be S of Q. And let's suppose this is the equilibrium level or the price line. So call that P, and these are the number of units that this production needs to sell to reach this equilibrium level or that price level. So the producer surplus, it's this area right here. So that's what we're looking for. This is what we're going to call the producer surplus. So it's the extra amount that the production will get, or you can think of it as the production or a company is selling their goods for more than their minimal price range. So the producer benefits. So instead of selling it for this much, let's say this quantity, you're selling it for much higher. So the idea is to sum up all of these rectangles right here using the Riemann sum. And as you construct infinite number of tall rectangles, we get that definite integral. So the area of this region, or the producer surplus, we're going to call that as a definite integral. So that would be the integral from 0 to Q. So we're integrating from here to here of the function. So the top function is some P, the price level, minus the supply curve S of Q. So that's going to be our formula for producer surplus. So this gives us the area between these two curves. So this one right here, the line, and the supply curve. So this area is the definite integral that you see right here. So let's go ahead and work that out for this particular example. So I'm just going to go ahead and erase all of this, and we'll try to figure out what will be the producer surplus for this particular example. So if a supply curve is modeled by this equation right here, so let's call that your supply curve, call it S of Q, and find the producer surplus when selling price is this much. So that's your price level. So call it that capital P, or the equilibrium level. So again, I'm going to draw another picture for you so you can see which region we're looking at. So when Q is 0, you have something like this. Let's suppose that is your S of Q, the supply curve, and $1,000, that's right here. And let's draw the line. This is the price level, or P. So the producer surplus is this region right here. This is what we're looking for. What's the area of this bounded region? So that means we need to figure out from where to where we're integrating. So we're integrating from 0 to this point right here, Q. So we need to figure out what is Q. What's the number of units this production has to sell? So let's go ahead and do that. So we'll set $1,000 equal to 600 plus 0.4 Q to the power 3/2. So you pretty much set this equal to 1,000 because you're looking for the number of units you need to sell. So solving it algebraically, so I'm going to go ahead and subtract 600. You have 400 is equal to 0.4 Q to the power 3/2. And then divide both sides by 0.4. You get 1,000 is equal to Q to the power 3/2. And then we raise both sides to the power 2/3. So you have 1,000 to the power 2 over 3 equals to Q. And that's going to give you about 100. Q is 100. So that means we need to sell this many units to reach that level. So Q is going to be 100. Now we're ready to integrate and find the producer surplus. So we know that the producer surplus is the definite integral from 0 to Q of the price line minus the supply curve, dq. So you're doing, think of it as doing top minus bottom. So if you create a vertical rectangle right here, your top curve is this one. So this is your top, which is the price line, and this is your bottom. So top minus bottom, we get all of these vertical rectangles. Summing it up from 0 to Q will give us the exact area. So continuing on, so P in this problem, it's going to be 1000. We're integrating from 0 to 100 because that's the limit of integration right here. So P is 1000 minus S. In this case, our S is going to be the supply curve, 600 plus 0.4, 600 plus 0.4, Q to the power 3 over 2, dq. And then we continue on with the simplification here. I'm going to distribute the negative. You have integral from 0 to 100, 1000 minus 600 minus, so distributing the negative out, minus 0.4, Q to the power 3 over 2. And we're integrating respect to Q. And then I can combine the numbers 1000 and 600 before integrating. So this is 0 to 100, 400 minus 0.4 Q to the power 3/2, integrating respect to Q. And now we can integrate the integral of 400, that's 400 Q, minus the integral of 0.4 Q to the 3/2. You add 1 to the power, same power goes on the bottom. Using power rule of integration, this is 0.4 Q to the 5/2, because 3/2 plus 1, that's going to be 5/2. So all over 5/2. And we're going to take it from 0 to 100. All right, so we're almost there. So let me just finish up the computation. This would give us 400 times 100 minus, now 0.4 divided by 5 over 2, that's about 0.16. And then I'm going to plug in Q, the upper limit. So right here, plugging this into all the Qs. So this will give us 0.16, that's this number right here. And times 100 to the power 5 over 2 minus. Now, when you plug in the lower limit into all of these Qs, you'll get 0. So that portion cancels out. So continuing on, I have 40,000 for first numbers and multiply them, minus now 0.16 times 100 to the 5/2. Well, that's taking a square root of 100, raising to the 5th power. You'll get about 16,000. And all of this together is 25,000. So that will be the producer surplus. So this is producer surplus.